Hey everyone, how you doing? Welcome back. We're on week 4, getting through this together, and we are going to be studying now the second part of protein synthesis is called translation. So if you can see in that picture here, we have our mRNA, and you should all be familiar with this because you just made this. And this is now going to be our tRNA, and it carries this amino acid at the top. So if we go to this, we're just going to kind of go over the different types of RNA because there are 3 different types. So just so you know what's all going on with it. So first one that we've talked about and you guys should be kind of familiar with is mRNA, which is also called messenger RNA. That's what the M stands for. And this is the message from the DNA, right? So the DNA sends a message out to the cell and says, this is what I want done. So it is the instructions from the DNA to send out into the rest of the cell. So this is called messenger RNA. So it will be copied from the DNA, which you saw and you did that with your last project, and then it's going to go out of the nucleus to the ribosome. And a set of 3 nucleotides makes what's called a codon. So if we look here we have our mRNA, and I put circles around what would be a codon. So it's always going to be 3 nucleotides. So we put them together like this. So this is going to be important as we go through translation. Then we have rRNA. Let me move this so you can see. rRNA. So this is called ribosomal RNA. So this is what makes up the ribosomes, hence ribosomal RNA. So the ribosome that's going to actually put together the protein is made of RNA. So sometimes, we've called them the protein builders or something to that effect. And they kind of look like this. This is where the mRNA and the tRNA are going to meet up here. Okay, then we have our tRNA. And this is called transfer RNA. So during protein synthesis, the tRNA is going to match up with the mRNA to build a protein. So if you see here, let me move this again. This would be my tRNA, and at the top of it, it has an amino acid up here. And down below, you have a set of 3 nucleotides. And this set is called the anticodon, where we had the codon, which were a set of 3 from the mRNA. It's going to match up with the anticodon with the tRNA. So the codon from the mRNA matches up with the codon from the tRNA. All right. And so protein synthesis is divided into 2 processes. So I'm going to go shortly over the first one again, and then we are going to go into the new part. So with our last week, what we discussed was transcription, which takes place in the nucleus. And that's where we had gone from DNA molecule is used to create a strand. Let me move this up again. A strand of RNA. So if we look at our picture here, we have DNA. And out of the DNA, we made a strand of mRNA, messenger RNA. So, and remember, if you looked at my video, what separated the DNA was this thing called DNA polymerase, which was the zipper, right? So it unzipped the DNA, so therefore we could create that strand of mRNA. So once it's made, it's going to then leave the nucleus and go to the ribosome to meet up with tRNA. So here's a picture of it. We had the DNA here. It was opened up or unzipped by the RNA polymerase, and then mRNA was created. So that's transcription. That's what we did last week. So what happens now is this mRNA here is going to leave the nucleus and then go find a ribosome. So next we have the second process, and this is what we're going to be talking about today, is called translation. Move this up. So translation takes place in the ribosome, at the ribosome, because remember that mRNA just left the nucleus and it finds a ribosome. So this part is taking place there. So this is where mRNA is going to meet tRNA at the ribosome. So the two of them are going to, go to the ribosome and have a little meetup, right? So, and as it does this, it's going to transfer that amino acid on, it's going to, when they connect, the amino acid on the top is then going to help build this protein. So it's going to meet up with the tRNA's anticodon. So the RNA's codon is going to meet up with the tRNA's anticodon. So these two have to meet. So here's a picture of this here, and I'm going to go more in detail with you in a separate video of this model. But we can see the amino acid building protein. So we can see these proteins are building here. But what happens is, and this is my ribosome, the yellow circle, and you can see here my messenger RNA has come into the ribosome, which is at the bottom, and my tRNA is going to meet and match up with my mRNA. So if you look here, I have a C and a G, they match up, a G and a C match up, and a U and an A match up. So this is what I'm talking about. The codon and the anticodon have to meet up. So like this one, G goes with C, UA, UA. So you can see this one has already dropped off an amino acid, but it was AU, UA, and GC. So now that it's dropped off that amino acid, it has gone out of the ribosome and then can be reused. Where this guy over here, this tRNA is just coming in to add to this building of the protein. And so again, the anticodon is here and the codon is here. So we can see where those two match up to connect the amino acids. Okay, so once the tRNA finds the correct codon, right, because the tRNA has the anticodon, it's going to match up with the codon to make that amino acid. I'm always having to move this. How about here? The ribosome will then connect each of these amino acids to form that protein. So here's an overall picture of it. So we have our nucleus here, right? And there's our DNA strand. And remember, we had made that mRNA out of the nucleus, out from that DNA, and it then left the nucleus and went to this ribosome here to create, see how it matches up with the tRNA, to create this protein. So here's one, another one coming in. Notice how the G's meeting the C, the G with the C, and the U with the A. So that's how it knows that's the one that has to come in. So behind me, we see that I have, this is going to be my ribosome. And in my ribosome, what's going to happen is translation. And what translation is basically doing is we're getting our mRNA and it's matching up with our tRNA, and from that we're getting that protein. So this is my mRNA, and this is kind of what it looks like, right? I have my nucleotides here, and 3 of them are going to be a codon. So here, over here, I have a picture of my tRNA. My amino acid is going to be at the very top, and as you can see down here, I have my anticodon, which are these 3 nucleotides at the bottom. So what happens is my RNA from the nucleus is then going to come into the ribosome. So I made another one over here. So my yellow circle in the back is my, sorry, I'm going to move this. It's my ribosome. Okay, so my mRNA here has come in and it's meeting up with my tRNA. So as you can see here, I have this coming in and it's going to be dropping off its amino acid. So this guy will come in and match up its codes, and then, oops, sorry, and then we'll be next in line to match up with these guys. This one has already left. It dropped off a amino acid here. Notice how it all matches here. So it dropped it off, and now it's out in the cytoplasm in the cell. So this one's coming in. So it's like a production line, right? So it comes in, builds up, drops that amino acid out, and then just goes on. And then the next one's going to come in and do the same thing. So he's going to come in, the mRNA is going to continue moving down so that it can build that protein.